recording. What's up? What's going on? Percentage of oxygen in air. They gave us what we need, 2 glass syringes, these two. Then a combustion tube, this thing that is connecting the glass syringes together. Then the copper wire, the brown thing that is inside over here. Then the source of heat. The source of heat is illustrated over here. This thing that I've circled, it's the heat. Then they told us what to do. Connect the combustion wire packed with copper wire to 2 gas syringes, A and B. This is, let me take this as A and take this as B. Then they told us that at the start, syringe A contains 100 centimeters cubed of air. Then B is literally empty. Then they told us figure 7.2, measuring the percentage of active air. Then it was 2 hits. Okay, like the method, what to do. 2 was hit the tube containing copper wire using a Bunsen burner. So the source of heat was a Bunsen burner. Then push in air as plunger. This thing is the plunger, as shown above. This forces the air into B. It like forces the air into B when A is empty. Push in B's plunger. When this has no air left, you push, like since it's pushing it to B, then you push in B's plunger after this is, after the air in A is over, forcing the air back to A. Repeat several times as the air is pushed to and fro. The oxygen in it reacts with the hot copper, turning it black. You get it? Like the oxygen, you like keep at first, and A has air, B does not have air. Then you use this plunge and push the air into B. Then when there is no air in A, you push the air back to A. Then you continue doing the same thing until the copper is turned black. After it turning black, you stop heating the tube. After about 3 minutes, and allow the apparatus to cool. Like then push all the gas into
Oh my God.
and measure its volume. You get it? Like the remaining gas after you push and push, like until the copper wire turns black, you put it into 1 syringe and then measure its volume. Remember that they told us that the air is 100 centimeters cubed. If it's 100 centimeters cubed, then we will see whether it's 100 centimeters cubed after measuring its volume. It is now less than, as you can see, it is now less than 100 centimeters cubed. Then repeat steps 1 and 2 until the volume of the gas remains steady. So you like repeat, you pushing the air and out, pushing the air and out, in and out. Then, and this means all the oxygen has been used. And why the oxygen is used, it's clearly that oxygen supports burning. So that's the main reason, like when the copper wire was heated, to continue that heating up, it was because of the heat, it was because of the oxygen, sorry. So they're telling us to carry out this experiment, and they're asking us what was the volume of, what was the volume? Let me first undo this. Okay. What was the volume of the air that remained? What was the volume of the air that was used up? Okay, yes, Kaihura Hannah. Your submission. Kaihura Hannah, you can give your submission. Hannah.
Yes. Good afternoon.
Good afternoon. Yes.
Every
Hannah. Hannah. Oh, I think she's been having some internet problems. The good thing the lesson is being recorded. So you guys, do you have anything to say about this work? Do you?
Yeah.
Yes, go ahead.
Yes, my soon, me, I have.
Okay, one at a time.
Nisha, that is.
One at a time.
I'm not
Okay,
still
yes,
like,
Yes.
I'm not still like understanding what you explain because I'm getting kind of confused here. Where I say that copper wires turn black and something. So I'm still not getting the point. Like it's still confusing me. I'm not getting.
Okay, the thing was the copper wire was on heating, and like when you heat it, it literally just turns black. Okay, like they told us to push the air from syringe A to B, then from B to A continuously until that copper wire, since it's on heating, until it turns black. That's what I was trying to say, that if until it turns black. So when it turns black, that's when you stop and let the apparatus cool. You get it?
So a little. Yeah.
Okay, Jana. No, wait. It was Ndagiri Nisha next. Ndagiri Nisha. Nisha.
my soon,
Yes.
I'm asking, you're hearing me?
Yes, I'm hearing you.
You see, in that process of pushing air to A and B,
Yes.
I'm seeing here they are saying that you push the air to B. Then how sure are you that some air is not going to escape and still go back to the syringe A?
Okay. A syringe is like something. Okay. Do you see normally the thing that like they used to inject you in? That injection, that big injection. So the thing, it's like it's completely covered.
Yes.
It's complete. When you push it, the thing has no space. It's completely like connected, and it's pushing the air, like it's pushing the air into this space that is left. Wait, it's pushing the air into this.
My soon.
Yes. You can go ahead.
My soon.
Yes.
Yeah, like what I'm trying to help Nisha.
Yes.
These syringes, when you push the air, like this bottom part where you hold that push the air, it's not like coming back, it's going like once, it's one way. So the air, it's not like the air is coming.
Yeah, it's one way. Thank you.
Oh.
Do you get it, Nisha?
Yeah.
Okay. So Janet, your submission.
I was just asking, is the use of that copper wire to burn? What's its use?
We will see as we go ahead in the experiment. We will see the use. Okay. So okay. So then they told us results. What was the volume of the air that remained? Okay, this one is kind of tricky because they told, okay, like oxygen, they told us that all the oxygen was used up. So it's 21% of 100 centimeters cubed. I think that's what it is. Do you guys have any submission to this?
First, repeat that statement you said.
Okay. I think was, okay, they're asking us what is the volume of the air that remained. I think that they're telling us to like carry this,
Yes, I did.
carry out this experiment, then we like measure it. Okay, it's like, I'm not really getting this because it's also quite complicated. You guys have any
My
submission?
son, you're not clear.
My son.
You're not clear.
Yes, yes, please.
My son, I think I know what to do when on that number.
Yes, it's, I think we are supposed to first carry out the experiment itself, then we like get what to do.
Yes.
Possible because we are not
Yes.
sure it's a COVID
Yes.
lockdown. So
Then I think after that, we subtract the first volume of air. We subtract the second volume of air from the first volume of air, then to get the air that remained.
yeah, the air that. So why did the volume of this number 3? I think number 3 is the one that is clear because it's like, why did the volume of the air decrease? Okay, personally, I think that the volume of the air.
My son.
Yes. Yes. Go ahead. Regina, wasn't it you who was? Let me continue. I was saying, why did the volume of the air decrease? This one, I think it's quite clear. Because it, okay, what I think why the volume of the air decreased, it was because the oxygen was used up during burning the copper wire. So do you guys have any submission to that?
I think that's it.
Okay.
Yeah.
Calculate the fraction and the percentage of the air used. The fraction and the percentage of the air used. We are supposed to, okay, to calculate the fraction and the percentage of the air used, we were supposed to first find the volume of air used, but since we are not at school, we have no syringes nor any copper wire. So let's just skip that. What is the conclusion? What conclusion can you make from your calculation? That also cannot be answered. Observation and conclusion. You may have observed that the volume of the air which remained less than 80 centimeters cubed. This implies that about 20 centimeters cubed was used, thereby causing it to reduce. Okay, the volume reduced because it reacted with the heated copper metal. Yeah, that's what I was talking about, the burning. It can be concluded that the active part of air is oxygen and it compromises 20% of the atmosphere. Okay, I think this thing has literally given us the answers. Because one of the things just said is that as long as, okay, like how the 21% comes in, is it okay, like how you can determine something like that the oxygen that has been used is 21%, it has to be close, or 21 exactly. It has to be close to 21 or 21 exactly. So I think that was it. That was briefly what we went through about this activity, right? Do you guys have anything to supplement about this?
Yes.
Yes, go ahead.
No?
Yes. Nisha,
Did you?
yes.
It's Hannah.
Okay.
Hannah.
Yes, go ahead.
Mason, did you write notes yesterday? I wasn't in the lesson.
The notes of what? The chemistry notes.
Chemistry.
My
Yeah.
connection was also kind of, yeah, I wrote something, but then it was also not kind of clear. But then in the video
Okay, Janet and
in the video that teacher gave us, I noted something that one of the uses of air helps to maintain like a stable temperature on Earth. Then
first wait.
Yes.
Maybe post your notes on the group. Me and Ingalls weren't in the lesson.
Okay. So I think that was clearly what we learned about, except when you guys want to read ahead in the separation of the components of air, because we never reached that step.
Yes, because it's the next
We
topic.
go ahead or we go to another subject.
Let's move to another subject and discuss
Which
from
subject?
this field and that field.
Which
Any
subject?
subject.
Okay,
Your choice.
History.
You guys, about history, you guys have not yet handed in your maps. The maps for the whatever thing in history. There is also math plus physics.
We shall discuss.
Okay. History, which page were we exactly on? Okay, let me check. What? As if I hear my name in the background of somebody. Okay. My question, please. Okay. We are nearing after. Well, on history, we're literally discussing about the centralized and uncentralized, sorry, the centralized and decentralized states. I think I've reached too far. You guys, do you guys remember the page? It was around, I'm still far. You guys can see my screen clearly, right? Can you guys see my screen clearly? Can you guys hear me?
Discuss them all.
Yes. Yes.
Although your connection is poor.
Yeah, my connection is poor. It's due to the putting on the video and also the muting. Okay, like which part of history? Because I think yesterday we were kind of too fast. No, sorry, the other day we were kind of too fast. So which part? Because we went through a lot of things. We went through the tracing, we went through the Maganda, we went through, then we were also given the activity. So which exact part do you guys want to go through? First, the trace where we started from. We started from.
Which activity did teacher give?
He gave us this. Let me scroll.
When did it?
Which activity?
You guys never attended the lesson. We're at the very end. It's over here. Yeah.
Yes.
Wait, let me first. We were given, okay, teacher told us to. Teacher said we draw. Teacher said we do number 1. Okay, teacher told us that we do number 4, and then you send it to me. Draw a map of East Africa and on it locate the selected centralized states. So you are supposed to draw a map of East Africa, locating the centralized states. Do everything a map has to be with. Okay, but then I've seen people send me, okay, so far 2 people have sent me the work. And one has sent me from number 1 to number 4. She has like described the origin of the Ankole and the Karagwe kingdoms, and also the factors that lead to the growth and expansion of the above kingdoms. Then she has also described the organization of the 19th Karagwe. Okay, this one was kind of tricky, but then it was just telling us to like the king, anything. But then for me, I just like went briefly about it. I just mentioned the titles of the kings, just to be brief. Then I also drew the map. So do you guys have anything to say about the activity? Or any questions to ask if you're confused? Do you guys have anything to say? Do you guys have anything to say? Or should I continue? You guys.
Centralized and decentralized.
Centralized and decentralized states.
We did those ones at school, the centralized and decentralized.
Yeah, we did the centralized and decentralized states. So should I move to another subject or just leave it like at that and I move to another subject, or we continue discussing just in case you have a
We
problem?
were given an
Pardon?
English,
Oh yeah,
and I understood that.
the recipe.
Yeah, no, there are some other questions. Write a letter.
Yeah,
I
yeah. Teacher told us to.
have them.
Teacher told us to write a letter. Teacher told us to write a letter in.
My son, I send you.
Yes. I have some kind of background.
I send a question. I have them.
You have the questions. Excuse me.
Yeah, I have them. Then you.
Okay. You are asking for the questions.
To share the question.
Oh, okay. Let me try because teacher never put. It was like it was not in the English prototype. So I was just writing them down. So let me try to write them down using Word. You guys can still see my screen, right? You guys can still see my screen.
My son, I've sent them. Man,
You
I
have
hate
sent
that
them.
bitch.
Okay, so you guys can get them.
I've already sent them to soon.
Okay. What else do you guys want to discuss? Maybe let me try going to YouTube to just check if it will work. To just check how you get the 21% in chemistry.
Have you got them?
Pardon? Oh, have I got them? Let me check. Yeah, I have got them. We were just told to do number 1, right? Then they told us that number 2 and 3 were to be done next time. So we're doing number 1. Okay, sorry, I was off because of some internet connection problems. Okay, is there somebody who has good internet so that they can share their screen, showing us how we get the 21% of oxygen in? You go to YouTube, then you share. Even if you have a phone, you can share. You guys, can you hear me? You guys, is there somebody with a good internet so that they can share the screen to show us how we get the 21% of oxygen?
My son.
Yes?
My son.
Yes?
If you want to have good network, okay? Contributing to the problem of the network. Just stay in darkness like some of us.
Lava. I would have shared my screen, but change WhatsApps every day. So now I don't have them.
Yes,
Lisa.
Regina, it looks like you have a very good network. China?
Hey, you go.
Mm-hmm.
I'm using a tab. I'm not using a laptop.
You can share.
Yes, you
even
can
if it's not
I
a-
share with my tab.
Yes, you share.
Yes.
Search Google how you get the 21%
Okay.
of oxygen. Then you tap on what? You tap on YouTube.
It has said the host is the only one who's supposed to be sharing.
Yeah, I'm pretty sure I changed those rules. Try again.
Only the host can share in this meeting.
Let me see.
Mine is allowing to share.
Yes. She's lying. She just
Hannah, you share.
Mama, you share.
Okay, I'm going to share.
Okay, share.
I am.
Let's see how good your network is.
Okay, have mercy. Are you seeing?
Yes, first,
Yeah.
scroll, yeah.
I go to Google. Then I say what?
Use you write how the 21%.
What do I type?
Okay, oxygen percentage. Search
Yes.
percentage. Oxygen percentage. Yeah, oxygen percentage.
It's there.
Then you tap on videos. Videos.
Videos.
Yes.
Which one do you want?
Let me see the atmosphere getting.
I scroll.
Yes. No,
What of percent oxygen in air?
yes, that one.
Yes?
Yes.
Which
that
one?
Percentage oxygen in air. Let's see.
Okay.
Nisha, what did you say after you
But it's
told me?
only-
What did you say?
Can you hear?
No.
Okay, I can hear you, but then you haven't shared your sound. Have you shared your sound in the beginning? No,
Tap
okay.
that small icon there
Yeah?
next to the other
First-
video. That small icon. I don't know if you can see it.
Which one?
First stop your share,
It's
then
there,
you
just
share
next.
again. And then you share sound and also optimize for a video clip.
First wait. I do what?
Please.
Okay, first stop the share.
My
Yes, first stop the share. First stop the share. Like you tap on stop sharing. Yes, then you share again. You tap on share screen. Then on your left, left down. On your
they
left,
have brought for me start now.
there is a thing in it that is share screen, and there is a box where you can tap on it and tick.
What?
It's like a small box. Okay, it's like,
Oh yeah.
yes, then also you
Okay.
optimize for a video clip.
Have I ticked it?
Actually, it's not sharing her screen. You guys have,
Okay. Nisha.
My son,
yes, I can see your screen. You can actually even go to YouTube.
We can see your baby face.
yeah, it's where I'm going. But it's taking me.
Then you
Take
search
away.
oxygen
What should I search
percentage
for?
in air. Oxygen percentage in air. By the way, this video is going to be put on YouTube.
So where should I tap?
What is that?
My son.
Yes, that
I
upper
should tap
one.
the video. This one.
Yeah, that one, and we see.
My son.
Yes,
Can you guys hear?
it's starting. It's still.
Can you guys hear the video?
Wait, it's starting. It's just starting. No, we can't. Does it have sound that side of yours?
Can you hear?
Does it have sound?
Yes.
I can't hear. Or maybe.
Should I tap here?
Have you shared your sound? Have you tapped on share sound before you like? No, that's not what I meant. I
No,
meant
I just
you were supposed to tap on share sound so that you can also, so that when you share your sound, you can hear the audio very well.
Can you stop recording? Because it's kind of embarrassing.
No, it's not.
My soon.
Yes.
Here it's bringing me Microsoft OneDrive, Google Drive, Box,
Yes.
photo,
Then
document,
down.
web URL.
Then you'll see
Go to
something down.
screen.
Then you'll
Go
see
to
something.
screen. Keep
Then
scrolling.
Then you'll see something
yes,
down.
I've seen screen camera.
There will be share sound down.
There is what?
Share screen. I don't know where if you're using a phone where
It's not there.
Okay, look around. There must be something like sharing your sound.
Let me try.
It's before you tap on share the screen.
Where should I tap now?
When you tap on share screen like this, then before you like pick the thing to share exactly, there is down. Like down there is something of, I'm not really sure on the phone where it is, but then on the laptop there is share sound. Even you can look around, there must be something like share sound, then also optimize for a video clip.
My soon, on a phone, there is only Microsoft OneDrive, Google Drive, Box, photo,
There
document,
is no share
web
sound.
URL. There is no such thing. Camera, screen share.
Maybe just tap on share screen and we see whether the video will work. Actually, I have poor net. You guys can see my screen, right? My network is.
Yes.
Yes, we can hear.
This transparent part of our environment reveals itself when it starts to move, trees and blowing snow. We live in the low portion of the Earth's atmosphere, a layer crop is. Most of the phenomena we call weather occurs in this layer. Air, of course, plays an essential role in life. Air is fully integrated into the chemistry of life. Carbon dioxide and oxygen flow from plant, animal, and back again, packaging and releasing energy from the sun. Air mediates the process. The significant knowledge we have today about the physics and chemistry of our atmosphere research and experimentation of a number of great minds, including the 18th century work of Scheele and Priestley, discoverers of oxygen. Others followed. They discovered the role oxygen plays in sustaining life. Air is complex. Scientists have determined that oxygen makes up approximately 21% of air, nitrogen 78%, and a number of other gases make up the remaining 1%. Carbon dioxide comes in at 0.04%. It is a testament to human ingenuity that we have found ways to determine the components of air. Let's look at a method for determining the percent of oxygen in air. This process relies on the fact that oxygen is highly reactive. Observe a fire and you are witnessing oxidation. Oxygen is reacting primarily with carbon in the wood in such a way that energy is being released at a fast rate. Carbon dioxide is one of the products of this process. Fire is an example of rapid oxidation. Oxidation can also be a slow process. Over a period of time, oxygen will combine with iron, producing rust. The reddish color on this metal roof is rust. Rust is a form of iron oxide, oxygen combined with iron. We're going to use the chemistry of rust to estimate the percent of oxygen in air. We need some steel wool. It contains iron. Also,
Are you guys
Yes.
hearing?
Yes.
Yes, we are.
tube, or the process is simple, as this animation demonstrates. Secure a small piece of damp steel wool in the bottom of the test tube. Rotate the tube and suspend it with the open end submerged in a container of water. Water being pushed up into the tube by air pressure. When the process, volume of removed oxygen. Let's set up some equipment so we can actually measure the volume of oxygen in air. There are a number of ways to do this. This is the method I used. These plastic tubes are calibrated in milliliters. I drilled a hole at the 10 milliliter mark. Will be the volume of air, as water will enter the tube to this point. A hole in the cap allows water in at the base. To increase the rate of oxidation, dampen the steel wool with dilute acetic acid, common vinegar. I used 5% acetic acid, diluted 50% with water. Remove excess liquid from the steel wool and push it into the bottom of the tube. The wide stand it in a container of water.
Okay, are you guys getting anything? Nisha, fast pause.
Right to the bottom of the.
Are you guys getting anything, or is it just me who is lost?
They tended to fall over without it. I set up two tubes,
Nisha.
one with steel wool,
Nisha.
one without.
Nisha, fast pause.
Yes.
Are you guys getting anything, or is it just me?
Me, I'm getting.
Talents are not getting what? Okay, maybe your keeps on pausing.
My number you.
I'm also the same. We are all lost.
Yes. Yes.
Okay, I can hear everything clearly, but then I'm not getting what the guy is doing.
Me, I've tried to get something.
Even
Okay,
mine.
what is he
But
doing?
mine is going smoothly.
Me too.
What is he doing?
Some experiments
Okay.
I don't understand.
Or what we just
Should I continue with the video?
who is getting and who is getting so that they can explain code to me?
Okay, this experiment here where I've paused, my son, you're getting?
Yes, I'm hearing you.
Yes, the volume of water, that is going to enter into that tube is equal to the volume of oxygen that has been removed from the tube, because it has occupied the space where the oxygen was.
So can you
get?
first take code back and I see exactly how it's happening, because I'm off and on, off and on, off and on. Like, can you just rewind the video and I see?
Forming iron oxide. This removes the oxygen from the air in the tube. The missing oxygen is replaced by water, being pushed up into the tube by air pressure. When the process is finished, the added volume of water in the tube equals the volume of removed oxygen. Let's set up some equipment so we can actually measure the volume of oxygen in air. There are a number of ways to do this. This is the method I used. These plastic tubes are calibrated in milliliters. I drilled a hole at the 10 milliliter mark. This will be the starting volume of air, as water will enter the tube to this point. A hole in the cap allows water in at the base. To increase the rate of oxidation, dampen the steel wool with dilute acetic acid, common vinegar. I used 5% acetic acid, diluted 50% with water. Remove excess liquid and put the tube. The wide cap allows us to invert the tube and stand it in a container of water, eliminating the need to use a test tube holder. I had to add some weight to the bottom of the tubes. They tended to fall over without it. I set up 2 tubes, one with steel wool, one without, a control, just to make sure that temperature fluctuations or some other effect wasn't influencing our results. With the tubes in place and the water levels at the 10 milliliter mark, I set up a video camera. The process is very slow. This time lapse covers 1 hour. In this period, the water motion makes up 2/10 or 20% of Earth's air. A good approximation. The color change tells us that the steel wool has rusted. This sample is fully rusted, flakes of rust falling from the steel wool. With this simple method, we have estimated that air is 20% oxygen, close to the accepted value of 21%. Some changes that would improve this procedure include using a taller, thinner tube. This would give better resolution of the scale, improving measurements. And we ignored the effect the steel wool had on the actual volume of air in the tube. Allowing for this would improve results. View our video on oxygen for a demonstration on how to collect and test oxygen. And for more science and technology videos and projects, visit our website, hiloroad.com.
So what should we do next, guys? Should I play another video or?
No, that's good.
No.
Okay, can somebody explain to me what you have got from that video?
We have got that it's 20% oxygen in air.
21% of
Air.
21%. Exactly, that was already known. Our mission was to like, how do we get the 21% of oxygen?
To the other experiment.
Yes, okay, can
I'm
I?
confused there.
Yes.
Yeah, I'm confused because each and every experiment we have been getting exactly 20%, but there is no experiment that we have gone 21%. So now where does that
I was actually on and off, on and off, so I'm not really sure. Maybe we should just leave it as an assignment. Then we like search how the 21% comes in through, and hoping if we have any Zoom lesson to come in next time. I don't think the link will change. I'm not really sure, but then just in case I change the link, I will WhatsApp you and inform you that I've changed the link. So let's just leave it as an assignment, and we'll like read ahead, and we'll post what we have got on the WhatsApp group, like the notes on the WhatsApp, the access discussion group. And another thing about the group, I've noticed we are diverting from the topic of education to just chat. So let's just try to make it specifically education, because we all want to get those bursaries, because one person gets it, at least one person from the group gets it.
My son.
Yes? Yes?
My son.
Yes?
You're starting to make that you're starting to make like that for Chanamdala. You know, like people run away from it. The access group, it's like to connect all of us. So
You-
those
you know that
chatting,
this
it's okay
lesson
because
is-
you're greeting your friend.
You know this lesson is being recorded.
Yes.
Yes, I know it's recorded because I can see it on. But let's not make it a group like for Chanamdala where we
Oh,
don't
no.
express ourselves.
You have got me wrong. I meant we have to chat, yes, just to like talk about ourselves and like we just laugh for the meanwhile, but then at least also post work, like double standards. That's what I mean. Not strictly only education, because that can be sometimes boring. That's what I was meaning, like both. It can be like both, but I've noticed you guys have been only that chat throughout. Nobody has posted whether they have any question about the math work or the physics or the bios or the chemistry or anything. So I just noticed you guys are like just chatting about possibility, then another person, then you like just find another topic, then TikTok, then. So I was like trying to bring it to its original self, because at first we were chatting while we were also posting work. For example, somebody has not attended the lesson, we post the work. For example, somebody has not done anything, we post the work. That's what I'm trying to mean. Like we keep the group fun and also the study kind, because each one of us wants to get that bursary, yet it's one person only one person getting it. And as you know, the average of Navisunsa is high, and we have repeated that class times.
Who said one person then get the bursary?
It's only one person.
No.
It's only one.
No.
One person.
It's
One person.
not only one person.
In the whole class of senior one person gets it, the best overall. So I'm pretty sure you all want to get it. So at least one person from this group, let only one person from this group get it. At least we will be proud that we have managed to put somebody out there. And moreover, we have repeated the class twice, going to the third year. So we have to revise and keep the study group on to not only chat. We have to chat just for fun, but also keep the study group intact. That's all I have to say. Thank you guys for attending. I think most of the people in the group have attended. Most of the people in the group have attended. So yeah, thanks, and I'm ending the meeting.